Okay, right, we're back and we're starting recording. And one last little bit of geology, and then I promise we'll get back to the biological side of things and build some bridges with what we were talking about earlier. For reasons that are not entirely understood, because this sort of thing is very difficult to study, it seems there are some points in the asthenosphere, that weak zone, the upper mantle of the Earth. There are some spots that happen to be hotter than other spots. And those hot spots, arm wave, controversy dodged. For our purposes, those hot spots hold still. Yeah, that'll do. They may not necessarily hold still. If you want to argue the point, go get a degree in geophysics. As far as I'm concerned, they hold still enough. And yet, the continents, the pieces of crust, are not holding still. They're moving over the asthenosphere. And every so often, you'll get a continent moving over a hot spot. The part of the continent that's right over the hot spot sees a boost in volcanic activity. That heat from the hot spot melts a lot of rock and creates volcanoes, including the largest volcanoes on Earth. But because the plate is moving, a volcano will be created, and then the volcano will go extinct as it moves off the hot spot. But then a new volcano will be created over the hot spot. And then that volcano will slowly move off the hot spots and go extinct, and a new volcano pop up, and so on. You get a chain of volcanoes that forms. This is not the same thing as an island arc. In an arc, like the Aleutians, for example, all of those volcanoes form at more or less the same time. And the arc is perpendicular to the direction the plate is moving. In a hot spot, the volcanoes are parallel to the direction the continent is moving. And the volcanoes on a hotspot chain form one at a time over, in some cases, many millions of years. And at any given moment, the newest volcanoes are on top of the hotspot. And the farther away you go from the hotspot, the older the volcanoes are. And once you're off the hotspot, the volcanoes go dormant and then ultimately go extinct. And exhibit A for a hotspot chain is Hawaii. So right now, the Big Island, here's the thing, Hawaii is the name for the state, which is a group of islands, but the largest of those islands is also called Hawaii. And most people just call it the Big Island. So the formal name of the Big Island is the island of Hawaii, but we'll call it the Big Island so that we're not confusing it with the name of the entire state. So the Big Island right there is over the hot spot right now, and that happens to be where active volcanoes are erupting. In fact, erupting to this day. I forget exactly when, because the pandemic has made time an illusion, but a few years ago, there was a lava flow from the Kilauea volcano that I think devoured a suburb. Yeah, that actually happens. There has been pretty steady volcanic activity since 1980 around the crater on the Big Island called Kilauea. Hawaii, the Big Island, has actually added a couple of acres of land where lava flows from Kilauea have reached the ocean. The island's actually built up. So that's where it is now. The active volcanoes are on top of the hotspot. As you go away, you get progressively older and older islands. Maui last erupted in, I think, 1793. Most of Oahu is a couple million years old. That has mostly gone dormant. Kauai is the oldest. So these islands form one after another. Kauai formed when it was on top of the hot spot. And then the plate moved away and Kauai went dormant and Oahu formed. And then Oahu moved off the hot spot and went dormant and Maui formed. And Maui moved off the hot spot, went mostly dormant, and the Big Island formed. And in fact, we can trace this far beyond where the actual state of Hawaii is. The state of Hawaii is down at the lower right, but extending to the north and west, you have a very long chain of tiny islands, none of them with a permanent population, and even some islands that are no longer islands because they've eroded completely under the ocean, called seamounts. And those extend all the way back into the North Pacific, almost all the way up to Alaska. So that big thing with an angle in it that you see in the center of this picture is the entirety of the Hawaiian hotspot chain. So the Big Island itself is, or the state of Hawaii is right there. The Leeward Islands are all of these islands to the northwest. The Leewards go all the way to Midway, famous as the site of a pivotal naval battle in the Second World War, the first real victory the US scored against Japan. Also called Midway because it used to be the Midway stop back when Pan American Airlines had flying boat airline service from California to China. They flew this thing called the Pacific Clipper that would leave California and make a stop at Midway, because Midway was pretty much midway across the North Pacific. Going all the way up to this submerged chain of islands that are no longer islands because they've eroded below the surface, called the Emperor Seamounts, named, by the way, for the Emperor of Japan because it was a Japanese expedition that discovered them around about the start of the 20th century. Right where Midway is, you can see there's a bend in that chain. Probably, maybe there's debate, arm wave, arm wave, arm wave, because the Pacific plate changed direction as it moved over the hot spot. So you have this bend. There's the state of Hawaii. Oh, by the way, the state of Hawaii is just that little bit down at the lower right of the chain, but the Leeward Islands, all the way up to Midway, are United States territory. Midway used to have a military base on it, although currently it does not. All of the other islands, I mean, some used to have lighthouses, and a couple of them people tried to settle, but they're tiny, they don't have much in the way of fresh water. There's no permanent population there today, but they're all territory of the United States. And I don't say this very often, but President George W. Bush did a really awesome thing, declaring all of those islands and the waters around them, I think for 200 miles, as the Northwest Hawaiian Islands National Monument. It's the largest in our national park system. It's bigger than all of the other national parks put together, although most of it is ocean. And it preserves critical habitats, coral reefs, and spawning grounds for commercially imported fish and things like that. And it's one of the most significant marine conservation initiatives that we ever did. And I disagreed with the man in many respects, but I will give credit for where credit is due. Thank you, President George W. Bush. So there. And it is possible to visit, it just, you'd have to charter a boat and probably get permission from various authorities, so it's not that easy to get to. But still, it's protected from things like commercial fishing, which can be very destructive. Right. So anyway, we can use radiometric dating based on the presence of radioactive isotopes and their daughter products to calculate the ages of volcanic rocks. And it turns out that the hotspot is right under the Big Island of Hawaii. The oldest rocks on the Big Island are about 700,000 years old, and the newest rocks are the lava that's cooling there today. I mentioned it is volcanically active there now, and very active. The Big Island, okay. In the center of the Big Island, there are two dormant volcanoes, Mauna Kea and Mauna Loa. You can actually drive to the top of Mauna Kea. There's a big observatory up there. When I was 11, we went to Hawaii and we actually did that. And it was pretty amazing. That's tall enough to get snow. You can actually drive up and ski in Hawaii. You can ski in the morning and then drive down and surf in the afternoon if you're so minded. Great place, love it, just real expensive. Anyhow, Mauna Kea, I think it is the largest volcano because it's nearly 14,000 feet high, but it grows from a base that's 20,000 feet below sea level. So the whole pile of rock that makes up the Big Island and Mauna Kea is a pile of rock that is about 35,000 feet above the base level of the ocean from where it started growing. So yeah, that's the largest volcano on Earth. And you know, the Kilauea volcano nearby is active currently. Maui, the oldest rocks are about 1.3 million years old, and the last eruption was in 1783. Molokai, 1.8 to 1.3 million years. Kaho'olawe is that tiny little speck that used to be a US Air Force bombing and gunnery range. That's where the Air Force would go to practice dropping bombs. They've actually given it up, and it's been turned over for the use of Native Hawaiians for them to practice their traditional culture and religion and ceremonies, or at least it will be once they clear up the unexploded bombs, of which there are quite a lot on Kaho'olawe. Oahu, that's where Honolulu is, that's where Pearl Harbor is, 3.3 to 2.3 million years old. And then Kauai, the oldest of the islands and also the most eroded. Like, even if you didn't have these dates, you could tell that Kauai was older because it has the smoothest terrain and the most eroded appearance. I mean, Hawaii looks like, the Big Island looks like a bunch of damn volcanoes. Kauai is a lot more lush and doesn't have these, you know, big conical peaks anymore. And that punches its clock between about 5.6 and 3.8 million years. Where's the next volcano going to be? Okay, like down here? If you said it's down here, you're right, and there is an undersea volcano. It hasn't broken the surface yet, and it may be many thousands of years before it does. The top of it is still about a mile below sea level, but it's been mapped. The University of Hawaii has put some remote probes on it, tracking its eruptions and how it's forming. It's called Loihi. And it will eventually, I mean, don't buy beachfront property on it just yet, but it will eventually be the next Hawaiian island, and actually it will probably join the big island of Hawaii and end up becoming a new peninsula that's part of the big island. But yeah, that is where the next is forming. And now we can finally get back to biology. Remember this is important, that the islands of Hawaii formed in a time order, that the oldest within the state are about 5.6 million years old. And as you go from northwest to southeast, the islands get younger and younger, and they're actually still forming. Hawaii happens to be home to one of those species flocks that I talked about. And it is a huge diversity of fruit flies in the genus Drosophila. That's your friend and mine, the common fruit fly, Drosophila melanogaster. And there are 700 species of fruit flies in the genera Drosophila and a closely related one called Scaptomyza in the Hawaiian Islands. As far as I know, most or all are restricted to individual islands, or in many cases, they might be restricted to individual valleys. Like if you are a fruit fly, you know, it may be, you know, and you're, you know, what, a millimeter long, it may be pretty much impossible for you to fly out of your valley and get over the mountain ridge and come down into the next valley. You know, that might be a barrier for you that's as formidable as a, you know, huge mountain range would be for people. And they're actually quite attractive. Most of them have developed these patterns on their wings. They're called picture-winged flies. There's some fly wings for you. That's just a few of the 700 Hawaiian fruit flies represented with all these patterns on them, all these picture wings.
In between that barrier, would that be considered vicariance?
Okay. In many cases, I would say no, because you would have a volcano coming up and then a new volcano coming up at some distance across the ocean. However, I wasn't going to get into this, but if you look at those islands kind of in the middle, Molokai, Maui, Lanai, and Kaho'olawe, right? Those four between 1.8 and 1 million years old. They used to be, the ocean between them is actually pretty shallow, and they used to be part of a large island that would have looked a lot like the big island does now. Today we call it Maui Nui, which I think is Hawaiian for ancient Maui, I'm not sure. Although the Hawaiians didn't call it anything because they weren't there at the time. But those four used to be one big island, and as that one big island moved off the hotspot, the crust actually sank down, separating Molokai, Lanai, Maui, and Kaho'olawe. So in that case, you could get vicariance. If the flies just stayed where they are, but the land sinks down, and now you get ocean barriers between separate mountains of what used to be one island, that would indeed be vicariance. On the other hand, as far as I know, like Oahu and Kauai have never been connected, and there's very deep ocean between them. So the only way flies could get from Kauai to Oahu or vice versa is going to be dispersal. But you could have vicariance in the case of Maui Nui, back when those four islands were one big one. There's actually, like off the north coast of Molokai, like right about where the word Molokai is, part of Maui Nui collapsed, and created what must have been an absolutely like freaking titanic landslide and tsunami. And there's actually a field of rubble, like an entire island collapsed completely and just went full, and rolled down onto the seafloor and made this rubble field that I'm not sure, it must be 100 miles long. So part of Maui Nui just collapsed and made this enormous undersea landslide that probably would have caused a humongous tsunami. At the break, I'll see if I can pull up a picture of it. Okay, so anyway, big diversity of Drosophila here in Hawaii. And notice that we can take DNA from fruit fly species and build a cladogram. And tomorrow we're going to do a lab where I'm going to show you guys how this is done. So everybody make sure you're on time. And this is actually some pretty old work. This is over 20 years ago. But when DNA was sequenced from some of these species, it turns out that the oldest branch was the branch on Oahu, Drosophila hemispeza. And then the next oldest branches were on Molokai and Maui. And the latest branches were on the Big Island. Now think about why this is the case. This is the case because when these fruit flies came, or at least when that little subset of the fruit flies showed up, Oahu must have been the only island that existed. So they set up on Oahu and speciated there. And then up comes Molokai and Maui, all of these volcanoes that would later become, Maui Nui. And some of those Oahu flies dispersed to Molokai, Maui, etc., and speciated there. And then up comes the Big Island of Hawaii, and flies from Molokai and Maui must have dispersed to the Big Island. I'm not saying you couldn't have some back dispersal, but by far, when you do cladograms like this, the older islands have older branches on the tree, and that must be because those older branches got there before the younger islands existed. So the ancestors of Drosophila hemispeza must have lived on Oahu and speciated there, and then some of them must have dispersed to Molokai once Molokai came into existence. And then some of those must have dispersed to Maui when Maui appeared, and then some of those must have dispersed to Hawaii. The branch pattern of the cladograms mirrors the order of appearance of the islands, right? See why? Because you can't disperse to an island before the island exists. This was a more recent, more thorough example that used a lot more species. And there have been a few cases of back dispersal. Like there's one case where a fruit fly lineage on Oahu somehow dispersed back to Kauai and formed a new species there. You can see that one thin arrow going from Oahu backwards to Kauai. And in one case from Maui Nui, a species dispersed back to Kauai. So occasionally you'll get dispersal backwards. And occasionally you'll get some jumping the line. You get cases where a Kauai lineage managed to disperse to Maui without stopping in Oahu on the way. So you get a few cases of backward dispersal and a few cases of line jumping, but in the great majority of cases, that pattern occurs by dispersal from older islands to younger ones. And it must be because those flies got established on the older islands and then dispersed to the younger ones as the younger ones form. Am I making sense there? And this may well have been going on even before Kauai formed. Remember that to the north and west of Kauai, you have all of these tiny little islands like Gardner Pinnacles and Necker Island and Laysan Islands. And those are all mostly just little bits of rock covered in seabird poop. But they used to be bigger. They've eroded since. And there may well have been fruit flies on those little pinnacles of rock that dispersed to Kauai when Kauai formed. So we don't really know how long this conveyor belt dispersal has been going. But it's been going for at least the past 6 million years in the case of the islands that make up the state of Hawaii. Isn't that freaking cool? Like, the geology tells you a story and the cladistic analysis tells you another one, and they actually match. I love it. You can tell the same story, by the way, not just about Hawaiian fruit flies, but Hawaiian crickets. The oldest branches of the Hawaiian crickets in the genus Prognatha brillis are the branches on Kauai. And then the next oldest are the ones on Oahu. And then the next oldest are the ones on Maui. And the youngest to branch are the ones on the youngest islands, the ones that must have dispersed from Maui to the big island of Hawaii. There's been a little bit of back dispersal. If you see those yellow lines in among the green and blue, those are cases where you had a lineage that was on Maui or the big islands that dispersed backwards to Oahu. But by and large, the pattern fits. The crickets must have gotten established on Kauai and speciated there. And then some of them dispersed to Oahu when Oahu formed. And then some of the Oahu ones must have dispersed to Maui and then the big island. So you get the same pattern in the fruit flies, in the crickets, and in Hawaiian spiders in the genus Tetragnatha. This is tricky because you have two lineages of Tetragnatha, so the story happened twice. But on both the left side and the right side, you've got the basic pattern of the earliest branches being on Kauai, a younger branch that ends up on Oahu, and then the youngest branches of all ending up on Molokai, Maui, and finally the Big Island. So it's the same story. You've got dispersal down this chain. And it works with the plants as well. One of the most striking Hawaiian plants is the Hawaiian silver sword. There's a population of it, I think it's Argyrosiphium virescens. It grows on the slopes of the dormant volcano Haleakala on the island of Maui. It's one of the things I remember very well when we visited there when I was 11. Yeah. We used to have family in Hawaii. You know, made the trip a lot more doable because we just crashed on their floors. And, you know, they fed us and all that. What's that? Well, here's it is because so many of the things you need have to be shipped. I mean, especially things like gas. But on the other hand, my mother's father's sister, my Aunt Judy, had moved out to Hawaii before statehood and founded one of the first travel agencies in the islands. And she was still running a travel agency on the island of Kauai. And we stayed with her. And she got us into all kinds of places by telling people that we were travel agents. You know, because, you know, tourist traps will want to attract travel agents because the travel agents will then steer people to come and stay with them. So we went to all these amazing seafood buffets, incredible food. Of course, you had to sit there and listen to entertainers sing songs by Don Ho. Tiny bubbles in the wine makes me feel happy, makes me feel fun. Okay, you may not know the songs of Don Ho, but he's very, very, very Hawaiian. And we heard them a lot. And, you know, you had to put up with that. The food was great, and we got into a lot of it free because my great Aunt Judy was a travel agent. Highly recommend that if you can manage it. Anyway, stop distracting me. It turns out you get the same story with the silver swords. The closest relatives to silver swords are California tarweeds. And presumably some tarweed seeds managed to disperse. Maybe they got blown, maybe they floated, I don't know. But somehow they managed to make it to Kauai. And they speciated on Kauai. And then some of the Kauai group later made it to Maui. I'm not sure why they skipped Oahu. And then some of the Maui group managed to make it to the big island of Hawaii. So yet again and again and again, when you do an analysis of the branching order of species, you find that it matches the story that the geology is telling you. And things actually come together. And you can see what these patterns of speciation by dispersal and vicariance look like projected on a really big screen, as it were, the screen of the geologic history of the Earth. Okay, let me see. I've got 11. This is actually a good spot for another break, even though I've only been talking for about 30 minutes or so. This is actually a pretty good spot to, let's take about 10 minutes and then come back and finish this off. Okie doke. All right, I will. It's a little early for a break, but this is kind of a convenient place to take a breather. So I'll stop recording.